Hello, everyone. We'll wait for people to join. See if I can. How is everyone today? Where is everyone watching from? That's the important question. I'm in Manchester in the UK, so it's currently very, very cold. And it's just about light out still, but I think it's going to be dark by the time this webinar finishes. Oh, lots of people from around the world. That's exciting. Everywhere from UK, India, California. Oh, Seattle, one of my favorite places. Awesome. Lots and lots of people. Nice to see everyone here. I will hide this in a minute. I'm just keeping an eye on it. So I think we had something like 1,500 people signed up. So we're just going to give people a few minutes to join. We don't want anyone to miss the start, right? But it's Wednesday, and certainly in Western cultures, we have the joke about Wednesday being halfway through the week. So how is your week going? What are your Wednesday wins so far? Other than this being webinar Wednesday now, apparently. Lots of you showing where you're coming from. Certainly lots of you from around the world, which is super exciting. Thank you for joining. Fixing bugs, oh dear. The win is getting some lemsip. Oh dear, Chris, feel better soon. Oh, last day of the semester, nice. Lots of you coming in from India, which is always exciting. Midweek win, I woke up early. Well, excellent. I woke up early as well because I was excited for something today. So I woke up like, oh. Got level 62 in Horizon Forbidden West. Nice. I've played Horizon Forbidden West because it came with my PlayStation, but it was surprisingly difficult. It was okay. It was just complicated. Okay, the numbers are sort of increasing steadily now and slowing down a bit. So we'll give it 1 or 2 more minutes and then we'll get started because we didn't come here to wait for people to join, right? But it's great to see so many of you. UK, Brazil, New Jersey, Berlin. Excellent. Lots and lots of people from around the world, which is always very exciting. Ecuador. Oh, nice. Okay, we'll get started just because, as I say, the number of you joining is slowing down a little bit now. So, we've given it a few minutes. We will, get started. As it says here on the slide, this is being recorded. So, if you've joined late and you feel like you've missed anything or you know anyone that's not been able to make it, don't worry. So, welcome in, everyone. I'm Luce Carter. I am a developer advocate here at MongoDB. I've been a developer advocate since the 1st of June last year. So it's been great. And I've really enjoyed working at MongoDB, which is nice to say. Even 18 months later, I still love my job. But my role as developer advocate is very much to advocate for you as developers. So, I talk to developers, I give webinars like this, I give talks, I write articles and blog posts, create content like videos sometimes. My job is to kind of talk to you all, understand how you use our products so we can make them better, how I can, listen to your feedback and provide it to our product and engineering teams. It's all a collaborative effort, but I always enjoy being able to give talks to people. So I'm really glad that I can be here today and talk to you about data modeling with MongoDB. So a quick one before we get started. Are you aware that we have just bear with me a second. There we go. Are you aware that we have a podcast? So if you are wanting to, consume some more MongoDB related content away from this webinar, the podcast is a great place to start. We have, it's on Apple Podcasts, Google Podcasts, Spotify. It's presented by my colleagues, Mike and Shane, who talk to customers, engineers at MongoDB, users that, lots of different people and loads of really interesting topics. So if you're interested in that, then check out the MongoDB podcast. And in fact, if you speak Spanish, we also have I believe it's called Unicode podcast in Spanish. But Diego is here to do Q&A. So one, thanks, Diego, but two, feel free to go ahead and share the link to that as well. So if you're Spanish speaking and you just want lots and lots of MongoDB content, then our podcasts have got you covered. Bit of housekeeping then to get started, because who doesn't love a bit of housekeeping to start a session? As I mentioned, this webinar will be recorded and shared. So if you've joined late, don't worry, you'll be able to watch it back. If there's anything in here that you want to, recap, it's fine. The recording will be shared with you later on. And it's not just people who've joined live. Anyone that's signed up and registered to the webinar, if you know anyone that couldn't make it, don't worry, this will be recorded and shared afterwards. All participants will be muted. So if you try to talk to me, I won't hear you. You will just be speaking to yourself. So make use of the chat box for any just commentary and comments like you've been doing about showing where you're from and your wins of the week. If you want to ask any questions about the content that I'm delivering, like maybe you want me to expand on something, or you've got a question, please use the Q&A box, not the chat box. We do have, as I mentioned, Diego in here, but also Dominic, who are both kindly handling Q&A. So we'll try and handle questions as we go. And if there's any questions that are worth talking about at the end or asking me, then we will save those for live Q&A at the end. Bear in mind that questions will be about this webinar and the content that I talk about. So if you come with your very specific use case about your project that normally you'd use something like our Ask the Experts product, it probably won't get answered. Same with anything that isn't about this webinar and data modeling. If you've got a completely different MongoDB question, please don't use a Q&A box for that. Please go and use the community forums where you can ask the questions, have them answered in public so other people can benefit. But also, there's only so many hours in a day, right? We can't answer all your questions, and so we'll try and keep this one today, please, to just about this webinar. And then at the end, there will be a short survey. Once we get to that point, that survey will go live. Please take a moment to fill it out. It's really valuable to us to get your feedback. And it's also a great opportunity if you've got any input about maybe future webinars you want to see. It's great for that because, we deliver these for you. And so anything you want to see, we're really open to your feedback so that we can give you the content that you really want to see. Okay, so the agenda for today, that's why we're here, right? To talk about data modeling. So what are we going to cover? Well, we'll start off by talking about the document data model. So, just understanding a little bit about how MongoDB models data with documents. Some of you may already be familiar with that. You may not. You may be coming from a relational world and, you're not so sure about documents. But of course, when it comes to modeling your data, it's important first to understand the data model. So we're going to go ahead and just cover a little bit about document data model, just some fundamentals that are useful to know. Then we'll talk about MongoDB Compass, which is our fantastic free GUI tool that's supported on Windows, Mac, and Linux. And this gives you the ability to not only, browse and manipulate your data, but there's also some other features in there that we'll look at, which can prove really helpful when it comes to data modeling and schema design. Then we'll go into the crux of this webinar, which is obviously modeling data with documents. So we'll talk about the kinds of things that you might, want to consider as we go through it. And that's, super important. Then we'll have a look at some design patterns and anti-patterns. So, there's going to be some, patterns, well-established, battle-tested patterns that you might want to consider when you're modeling your data. So we'll talk through those design patterns. But there's also some anti-patterns, things you actually want to avoid, things that, big red flag, big red cross, you want to avoid. So we'll talk about those anti-patterns as well. And then we'll finish by just having a look at the schema advisor, which just gives you the ability to actually get MongoDB to give you some advice based on your schema to maybe improve the schema, improve performance, anything like that. So, quite a lot to cover today, but I'm very, very excited because data modeling is just an really important topic because, if you're going to start using MongoDB's document data model, you want to get the most out of it. You want to use it in the best way possible. And so data modeling is a real fundamental foundation for actually going ahead and making the most of it. So let's start. In MongoDB, we have this mantra, something that you'll hear everywhere. You'll hear it multiple times in this webinar. You've probably heard it multiple times in other content if you've ever seen any talks or videos or anything like that. And if there's one thing I want you to take away from today, one message, if nothing else, I want you to remember this mantra, which is data that is accessed together should be stored together. This is a mantra that you need to remember and kind of have it flow through the core of all your decision making around data modeling, because it's just so important. But of course, data is not all created equal. There will be times when we don't want to access all the data every time. So we'll also spend some, the whole point of this is that we'll talk about how MongoDB can store related data in different ways. Can be stored together, but we will also cover some alternatives. So let's just go back in time a bit. Let's just go on a bit of a journey together, back actually to before I was born in the 1970s, when people looked like this. They smiled a lot. They had weird hand poses. They had their feet out. They had some very strange outfits. I like the color orange. I'm okay with that, but these are very strange outfits. But back in the 1970s, there's also this man by the name of Edgar Codd. And he worked for a little known company called IBM. Heard of them? They were known for making computers that looked a bit like this. Massive things. You think about, in this day and age, we have computers in our hands that are palm-sized. So it's funny to think back how big they were back then. But these computers also had gigantic disk drives that look like this. And I know it's just the lighting in this photograph, but is it just me, or does the guy in this picture look a little bit like one of these? If you know the reference, this is an Oompa Loompa from Charlie and the Chocolate Factory, or Willy Wonka, or whatever you want to call it. But anyway, yes. These are disk drives from the 1970s, huge things on trolleys that someone had to push around. But the problem is that these huge disk drives also cost this much money, massive amount, not exactly cheap, right? Back in the 70s, one megabyte, one tiny little megabyte of data would cost about $9,200, which is huge. But in this day and age, in 2022, 1 megabyte, even though you never need 1 megabyte, because obviously, these days we deal in gigabytes, terabytes, petabytes, get huge. But yeah, if you think about it in today's money, 1 megabyte would cost about $0.00002, which is nothing, right? Storage isn't expensive like it used to be. We've come a long way since then. But back in the 1970s, as we say, it was expensive, super expensive. And so Edgar Codd came up with a set of rules of normalization. And these rules were intended to just help reduce the amount of storage you needed, because, well, as we've just talked about, when he came up with these rules, storage was incredibly expensive. So, one of your key priorities when it came to data was trying to reduce your storage, because reduce the amount of storage you need, reduce those costs. And actually back then, storage cost a lot more than developers' time. So no one really cared about developers' time, it didn't matter. So Codd came up with these rules that the developer could implement, and that was fine. So when you model data in a relational database, whether it was something like SQL Server or Oracle or Postgres, whatever, you'd have to go through this process of normalizing these data elements, which essentially just spread the data out into appropriate separate tables. And this was something that developer did. As I say, back then, developers were cheap, so no one really cared. So it was all about trying to optimize for lower storage costs. And so we can look at it another way in terms of what's happened over time. And as you can see, there's been a rapid drop. Once you get to sort of 1980-ish, it starts to dramatically drop. And these days, it's so much cheaper. So when, you know, COD introduced these rules in 1970, it cost a lot. But now we're in, you know, something like, we're using something like MongoDB. When MongoDB was created, you'd have, you know, costs have dropped massively. And so you come back to 2007, as you can see, it's much, much lower. So actually, when you think about, you know, where we were then, even back in 2007 and where we are now, does normalization really still make sense? You know, do we actually need to be constrained by the cost of data storage? Well, no. And so that's why MongoDB was born. You know, we don't need to worry so much about these constraints anymore. And so here's a fun way to visualize this. And I love this. I think it's great. So imagine you've got a car. In a traditional relational database, you'd have a tires table, a seats table, an engine table, etc. But then you'd have to join everything back together again when you wanted to drive the car. Yeah, you can't just say, oh, you know, I don't want to use the brakes today, or I don't know, we don't need these bits, we don't need those tires or whatever piece of car it is. No, you need every piece of the car to drive it. Now, okay, I'm sure, you know, some pedants here might argue that some tiny little bits of a car that you don't need, but you get the idea. The parts are stored in separate tables, but you still need them all together in one when you drive the car. So in a document database like MongoDB, instead, we store things together. The car is stored as a whole in that garage, which is just, you know, really, really helpful and important. It's all together, ready to go when we need it. And remember, data that's accessed together should be stored together. So our car is accessed as one car with all its pieces. So we store it together as one car in its garage. So it really does go from relational to document databases really requires a shift in your approach. You know, you need to think about the application first. It's not so much about how you store the data, because, you know, back in the 1970s, you know, data had to be normalized. Normalization was ingrained in us. You had to do it. You know, you had to break things down into these little tables like you see here. But actually storing data in documents just requires a slight shift in thinking now, because we can go from tables with relationships to documents which can contain embedded data. So rather than these different tables here, you know, you've got the name, which is an object or embedded document, as we call it, with the first name and last name. The address is an array with details and so on. You can have more than one address. The document here is representing exactly the same data and data structures as the relational side. It's just doing it in a way that makes more sense. It's accessed together, so we store it together in one document. Now, we're just going to have a quick look a little bit more. And if you want to play along with this, you can. You can just go to cloud.mongodb.com, sign up for an account, and join in if you want. If not, don't worry, try it later, or, you know, maybe you've done this before. But, you know, we can come in and we can actually have a look. So you can start to create databases. So you could say, you know, create a database, and then you can pick the type. Now, what's super, super cool, right, is that if you click shared clusters, you can have there's a special type of shared cluster called an M0, which is free forever, and you don't even need to enter your credit card to sign up, which is awesome. All you need to do is just click shared, click your cloud provider that you want to use. It doesn't make a huge difference which you pick, so I always just leave it as AWS, because why not? Pick your closest region. And then, you know, you can leave the rest by default. You can give it a name if you want, but the default is cluster 0, but I've already got one, so you can just leave these. Click create. It will go ahead and, you know, start to ask you a few questions about setting up a username and password. And then, you know, do you want to access it from a local environment, which 99.9% of the time that you do. Add your, you know, you can ask it to add your IP address, because we have security out of the box. We won't let you access it from anywhere unless you explicitly say either add my IP address, because I want this IP address to access my databases, or go a bit rogue and say access from anywhere. We strongly discourage that. But once you do that, you'll have a database cluster ready to go, like I've got here. I've got quite a few, but we've got this cluster 0, which is an M0. like I say, free forever. Don't even need to log your credit card details. And then you can go ahead and browse it if you want to. And you can just start to see the different data. Now, one thing to note is that if you want to have a look at the data and actually have some yourself, so some to play around with, you can actually click these three dots here and click load sample data set. And what this does is it just gives you 350 megabytes of data in different shapes and sizes that just give you an idea of what we can do, but also just give you some data to play with. You know, if you don't have any data yet and you just want to play around, just use the sample data set. Yeah, and then you can have a look at here if you want, and you'll see all these different databases. If it starts with sample underscore, that's what you'll get to from that sample database. So, you know, you can do the same yourself. We have all sorts. We have Airbnb listings. So that's, you know, pretend Airbnb with things like, you know, details about it, the property type, stays, the, you know, reviews, the kind of things you'd expect. And we have all sorts, and we even have this Mflix, which is a bit like an Netflix clone. So there's sort of movie information in there as well as other things you might expect. So as I said, if you want to go ahead and do that yourself, you can. And so we saw we could load that sample data set, go ahead and go through it. Yep, just load it, and then take a look. So as I said, you know, we looked at that Mflix briefly. And so let's just take a closer look in a slide that's easier to read. So for the sake of this webinar, we're going to pretend that we're making an application that allows us to work with movie data. And so we're going to use the sample Mflix. So this is an example of a document from inside that sample Mflix database. So, you know, you've got things like the underscore ID, which is a special type of object ID, which is our primary key. Has to be unique and it has to be present. But things like title, year, plot. But what's cool is that documents in MongoDB are a JSON-like structure, but they're actually BSON or binary JSON, which means that they support more data types than just your basic JSON. So in JSON, for example, we'd have things like dates stored as strings, whereas with BSON, in fact, you can just store them as an ISO date, which is awesome. And the way this is done is that with BSON documents, basically, they have an extra couple of bytes on each field, which actually specifies the data type when it's stored on disks. And so that's great. It just gives you that extra information that can be really useful. So relational databases were designed to save on storage space. MongoDB documents were designed to optimize on your time to make your life easier and more productive, because you know, lots of us have been developers. Either you still are, or you have been, or you work with developers. Anything that you can do to make developers' time easier and more productive is a win. You know, I don't want to have to spend more time than I need to doing certain things. So, you know, very much MongoDB is a developer focused, and so these documents are there to make your life easier. And you know, you can see there's all sorts of different data types here that we'll see a bit later on. So this, as we saw, is our sample data set, and we saw lots of other different types, and you know, you can view it and you can see all sorts of different things, including schema anti-patterns that we'll talk about later on. Okay, so we know a little bit about our data model, and you know, as I said, we're going to have a look at Mflix for this, because it helps to kind of target a specific set of data, right? Because it helps you work through it and visualize it. And personally, I find that a much easier way to learn. I'm a learn by doing type. So let's just have a quick look at Compass. As I mentioned, you know, it's our free GUI tool. So the first time you open Compass, you'll be met with a screen very similar to this. You maybe won't have recents, but you know, you can connect, you can do new connection, you can disconnect. You know, it's going to have a very similar feel to the Atlas browser in your actual internet browser, but you know, it's still a really great tool. And so one of the things we can do is we can connect to our cluster, for example. So this is one that I've already connected to, and it's the one that we looked at before. So you'll see on the left, same as in Atlas, it'll all look and feel very familiar. We will have these sample databases, exactly the same as we saw before, that we can browse, including, you know, movies. We've even got geospatial, for example. So if you've if you've got anything that involves coordinates in GeoJSON, we can support that. So we've got, we've got shipwrecks, and so shipwrecks has an array of coordinates, for example. And, that's great. And there's lots of other things going on. So like we've got the schema, you can ask it, hey, analyze the schema, and it will notice things like, oh, look, coordinates. This is coordinates, right? So why don't we display them on a map? That's helpful. So you can do that from the schema tab on your collection right here in Compass. But what's cool is that all of these are just charts from our Atlas product charts, which means that if you want to recreate something similar, so say you've got coordinates data and you want to see them on a map, charts, you just, point it at the data source collection that you want it to look at, and then say, hey, I want a map, and point it to the coordinates field. So, these cool visualizations here aren't limited to just the schema tab. I just like that it can very quickly analyze your schema and give you lots of information, like the type of the field, information about it, visualizations that might be useful to you. And then we've got the aggregations tab, for example. So with aggregations, it allows you to essentially do complex computations on your data in stages that kind of, it will start off with your collection as it's stored. You can then do what we call stages on it. So the output from one stage will be the input to the next. So you can start doing quite complex steps to it. And what I like about Compass is it allows you to actually visualize it by trying it out in here. So the different stages you can do, like count, for example, you can select it and then you can fill things out, and then it will actually return you examples of what the output will look like after that, based on the documents that you've got. And if you then did something on this stage and moved on to the next, it's all there. But I just thought this is cool to show you, because Compass allows you to actually build it up visually. And then if you're a visual person and this helps you, and then you're like, right, I've got a pipeline that's doing what I want it to do with all the right stages in the right order, you can actually click export to language. And then, you can pick your language from a drop-down box. So, C#, for example. So it will actually give you the ability to just copy and paste it into your language for your application. So super, super cool. And aggregations themselves is completely outside the scope of this webinar. We've got lots of resources and even possibly other webinars on aggregation framework. But I just wanted to show you it in Compass because I think it's cool that we've got this nice visualization. So if we come back to here, yep. So that was Compass. And yeah, you can see that we can look at the documents. And in fact, one of the things that you can do that obviously you can do in Atlas as well is, of course, it's not just view the data, you can edit it, copy it, clone it, or delete it. Zoom in a bit, so it's a bit bigger. Yeah, there you go. So there's lots of things you can do, or you can add data from a file, or you can insert a document. So Compass is just a cool tool that not everyone knows about. So I just wanted to tell you about it. Okay, so let's start to talk about data modeling a bit and actually thinking about your application, pull the thinking face, have a moment. Because in the relational database world, when you start thinking about your data, you think about it in terms of breaking it into tables, right? Well, now instead of thinking about it in terms of tables, I want you to think about it in terms of how that data will actually be used. Because we don't need to worry about storage anymore. We care about developers and their experience and the applications. So it's all about how the data will be used. So there's a few basic questions we want to start asking ourselves. So the first one is, what does my app do? So in the case of our sort of pretend hypothetical app that we're going to talk about today with the MFlix data, it's, well, I want to present movie data and view that data online. What does my data look like? We want to identify and model the relationships between the data. So, with movies, it's going to have movie data that will have a title, a release date, at least one director, a rating, and often an image associated as well, like the main image. And, there's lots of other information as well. But, we can start to identify how these bits of data might relate to each other. Then you want to ask, well, what tooling will I use? Am I going to use Python? Am I going to use C#? Am I going to use JavaScript? Am I going to use a driver? Am I going to access it over an API with REST calls? And also, How can I apply proven patterns? How can I apply successful patterns to the use of my data? And we'll go, as I mentioned, we'll go more into patterns, both design patterns and anti-patterns as we go through this webinar today. But yes, when it comes to kind of the first stage, it's very much asking yourself these questions, because these questions will help you answer some decisions we're going to cover as we go through this. So I want to go over a few terms first. These terms are kind of important terms I want to make sure we understand before we start using them in things that we learn later on. So polymorphism, so poly equals morph equals shapes. And so that literally means many shapes. So in the case of documents in MongoDB, that means that they can have many shapes. So you might be thinking, okay, well, I've heard MongoDB is schemaless. Well, that's not quite true. With MongoDB, there is a schema because it's binary JSON, so it has to, fulfill the basics of a JSON schema, like having curly brackets and field values, and there's certain, it supports a wider breadth of data types than just the JSON data types, but there's still a limit. So there's still a schema, but the schema is flexible. Not every document needs to be the same shape or size. It's okay to have documents that don't have certain fields if you want to. So that's what we mean by polymorphism. It's just this idea that your documents can be different shapes and sizes. Then there's embedding. So this is the idea of documents within documents, even within documents. So you might have seen that in some of our documents earlier that we had we had a field in the document that then was an object, so curly braces, which is an embedded document. So you can actually embed documents within documents. Then there's referencing. So, you can also reference in a similar way to the way you would in a SQL application. And we'll cover the two concepts of embedding and referencing and how they differ from each other as we go along. And also performance. Performance is a big driver for decisions. So it's a driving force behind whether you choose embedding or referencing for your data. And there's a common question that I'm sure some of you are actually asking yourselves right now, and that is when to embed and when to reference. And we will come on to that as we go along. But performance is very much a key influencer of this decision. Okay, modeling relationships. Well, a flexible document model means that one document can look completely different to the next one. As I mentioned, flexible schema means that it can look slightly different if you want it to. You can, store the documents that have other documents nested or embedded. You can use normalization so that you choose whether to use references or not. It's not necessarily normalization in the way that you know it, but it's still normalization. And that's, we can use database references if we want to. But what you really want to focus on is how your application is going to reference or use that data. Because as we say, data that's accessed together should be stored together. You need to think about how your application will use the data as opposed to how it's stored, because how that data is used is what's going to be that driving force for how you model it. Like I said, data's accessed together should be stored together. You're going to keep hearing this. It's super, super important. So let's just double check. Cool. I'm just making sure I've not missed anything important. Yeah. So as I say, data that's accessed together should very much be stored together. Okay, modeling relationships. This is what we're here for, right? A bit of holding hands. Modeling relationships is really important. And so before we've covered that, let's just quickly touch on a bit of, end it with a bit of summary mapping, because you've heard me, you might have been able to kind of pick these up as we go, but just make it really clear, because if you're coming from a relational database world, it's really, really important that you kind of see the relations here. No pun intended, maybe a little bit. So rather than having a table of rows of records, instead we have a collection of documents. And then rather than columns to specify the, we have fields instead. So it's kind of going from like that to like that. So there's, in many ways, there's lots of similarities in terms of, you have groups of information stored together, but in the document case, it's a document in a collection, and often rather than having multiple tables, we keep things in a collection. Okay, relationships, very important. So let's just take a minute to remind ourselves of the different types of relationships. So we've got one-to-one. So that's one entity maps to another entity or document, whatever you want to call it. So for example, in our movies, that might be, you know, one movie has one title or one release date or one rating, you know, lots of different one-to-one relationships potentially, but it's just this idea of one thing maps to one thing. Then you've got one-to-many. You know, one thing can map to many things. So one movie often has as many cast members. Yes, I know you can have movies that's maybe a single person monologue, but on the whole, one movie is going to have many cast members. Then we've got many-to-many. So it might be, you know, films are often shot on location, right? Whether that's in a studio or actually out and about in the world. And often, even in even in many different locations, there's many more specific places within that location. So it might be, for example, here in Manchester, some of the architecture looks a little bit like New York. So actually often there's parts of Manchester that get shut off because things like Marvel decide to come film here because it's cheaper to make it look a bit like New York and film here than it is to film in New York. So, you know, many locations can have many specific areas in that location. So in Manchester, there's multiple locations, or, you know, many different countries, a film is filmed in many locations, in many cities within that location, for example. So if we just take a quick, you know, a slightly deeper look at that movies, and we just take one movie, for example, Lord of the Rings, Fellowship of the Ring. Got one title, one rating, one runtime, but it can have many genres. So one movie can have many genres, might have one, it might have many, but it's quite capable of supporting many, even if it's only been given one genre. You've got a director, in this case, it's just Peter Jackson, but I'm sure there's films that can have multiple directors. There's often multiple writers. So you can see there's lots of examples, even just in this one document, of the different types of relationships. And of course, there's cast as well. Obviously, these are just the big names, but there's many others. So when we think about modeling that one-to-one relationship, let's just take a quick look at it. So in a traditional, you know, tabular relational method, we'd have a movie table, and then that could be related to a movie details table with, you know, the movie ID being common between them. So it's primary key in movies table, and then the secondary key in the movie details table. In MongoDB, we could do the exact same thing. So we have a movie collection and a movie details collection, and we use that movie ID as a reference. Or if this data is accessed together more often than not, we could just have one movies collection that embeds all that information together, the ID, that title, that director, and that runtime. So, you know, not just the title, but also the details as well. Data that's accessed together should be stored together. Okay, many-to-many relationships then. We have a cast. Often many casts. Now, a movie can have multiple casts in a single movie, and we can see that there's many casts related to one movie, and that's where that movie ID foreign key comes in. Again, we could do exactly the same thing in MongoDB. We can have a movies collection and a cast collection, and then use the movie ID in each cast document to link back to that movie. But again, if this data is going to be accessed together, it should be stored together. So we could just have one movies collection that stores all that data together. And this is because, you know, embedding often makes queries more efficient. If you're going to be accessing the data together, you know, store it together, use embedding. And nested arrays like this, with an array of documents, or embedded documents, or nested documents, whatever you want to call them, is a great way to model one-to-many relationships. So the cast, as you see, is an array data type, and then you can just use one single query to retrieve all the data you need, because often, you know, you want to know the cast of a movie. There's no point storing them separately. You want to keep them together. So you just have this array of embedded documents for each actor and their character. Okay, Next, modeling many-to-many relationships. So we can have a movies table, a locations table, and a movie locations table. And we can see that each of these are related to each other, and that's creating that many-to-many relationship. And in MongoDB, we could do the same thing. We could have two collections where we've got the movies collection that references the filming locations by object ID. And then in the locations collection, we've then got the ID and that all the data is together. If it's accessed together, it should be stored together. So we can just, you can keep using back referencing if you want here. So not only do we have the object IDs mapping to the IDs in the locations, but in fact, the movie's object ID is also mentioned in the location. So we've got back references. But data that's accessed together should be stored together. So instead, we have this one movies collection and we embed all the data in there with its filming locations as an array of embedded documents. And I'm going to keep saying it. Data that's accessed together should be stored together. I'm going to keep saying it until you remember, because there's so many relationship situations where in the relational world, you think about, these different types of relationships and you automatically, often try and sort of recreate it in the document model. A lot of the time, embedding is your best friend. But as we saw, if you want, you can do referencing. You can have these separate collections where you then reference by ID to form those relationships. So it's not always embedding. You can reference if you want to. So let's just quickly have a look at some pros and cons of embedding versus referencing in MongoDB. Well, with embedding, when you embed data, you can use a single query to retrieve that data, and this is much more performant. Remember earlier I talked about this idea that performance will play a key role? Well, if performance is important to you, embedding is helpful because you use that single query. You can use a single operation to update or delete data, reducing the amount of writes needed. Again, performance and efficiency. But there are downsides, of course. You will likely have data duplication and possibly even larger documents. But just remember, data duplication isn't necessarily a bad thing, depending on your use case. Now, I appreciate that, to a lot of people coming from the relational world, the idea of data duplication sets off alarm bells in their head. It's okay. Actually, it can often be more efficient, believe it or not. And then we've got referencing. Well, with referencing, there's no data duplication because you're referencing rather than embedding the same data. And you'll most likely have smaller documents. Because you're not embedding that information, but instead doing referencing, chances are your documents will end up being a lot smaller. But you'll have to join the data from multiple documents, which can decrease performance because it just requires extra resources, whether that's read time or performance or efficiency. It does, come at a cost. So, these are things just worth considering when you're thinking about whether to pick embedding or referencing. Again, with document databases, we have the ability to choose. It's not just about always embedding or always referencing. You can decide which works for you. You should use embedding when you've got data that's accessed together. It gives you fast read, but it does give you slower writes if the embedded data is duplicated in other areas and you need to make sure it's always updated. So, there's times when referencing may be better. And that's when data that's infrequently accessed together, because it gives you faster writes, but if it's not always being accessed together, it doesn't matter. But it will give you slower reads since you'll have to reference multiple collections to join the data back together. It's like saying, hey, mechanic, build this car back together again versus, how long does it take the person to jump in a car and drive out the garage? There is, slower reads. There is a cost to referencing and embedding. It's all about, your use case. Remember what we said about thinking about how your data will be used. That's the key to making these decisions. You have to decide what's more important. Do you want faster reads or faster writes? Does your data change a lot? You might want to separate the data so you don't have to update data in multiple locations. Does your data actually not really change a lot? In which case, you might just want to embed the data because you get faster reads. If reads more important than writes, that's when embed comes in. Okay, what do you think is the default preference? Not that one. What do we think? I want the other box. Let's get the chat up. I want the chat so I can see what people are saying. There we go. Embedding. Yeah, there we go. See, you're all super smart people. Absolutely. Embedding. That's what we want. Embedding is definitely the preference. As we keep saying over and over again, like a broken record, data that's accessed together should be stored together. So more often than not, embedding is your answer. Yes, as we've talked about, there are times when referencing is the answer, but you'll find majority of the time, if you're modeling your data in the right way, embedding is probably going to end up being the most common. So let's just have a look about evolving your data model a little bit. And so imagine you've got a users collection, because users are the most important people in your application, right? Normally. So imagine that you've got this first user, Homer Simpson. So on day one, you've just got this, one user, Homer Simpson. He is your starting point, your first user, your excited first user. But then you realize on day two, wait, I can't sort by name. So then you start into this name object. So you've got, given name, middle name, family name. And then you can sort by family name if you want to. If there's one thing, we all know, there's one thing in life that you can guarantee, apart from death and taxes, is change. You might have new feature requests, you might have market conditions changing, but thankfully MongoDB's flexible document model makes evolution simple. You can simply add or change a field in your application. So you can add things, you can remove things, you can change the shape of it. So we've gone from a single string value for name to being an object instead, and that's okay. As soon as you write the next document, that document can be in whatever shape that you want for what works for you. Now your data's evolved. Now, okay, that's fine. We talked about writes. When you make the writes, that's easy enough. What about reads? Well, this is when we might want to introduce the concept of version control, because actually, with all things as they change, it might be super important to be aware of the fact that you've made a change. It's okay to have a flexible document model because that makes evolution really simple. But sometimes it's important to know that things have changed. And one of the things you can actually do is introduce a field in your documents called version. So you can, straight away see what version of the schema this document is from. If that's important to you, you can. There are ways to keep track of how things have changed over time. But another thing that's super important, of course, is schema validation. You can actually validate the schema on insert or update if you want to ensure that the data conforms to specifications. Because yes, we say that it can, we can support the polymorphic pattern with different shapes and sizes, but the idea of having, this flexibleness in the way that documents can change might fill you with dread and panic. That's okay. We have schema validation. And this can be applied to new or existing collections. And you can create various levels of enforceability on that, either using the JSON schema or using other types of validation, using things like expressions. So you can validate data on insert or update, and you can say, you can set different validation levels. So you can say, I want it to be, warn or reject, or you can decide, okay, actually there's different levels I want it to apply with validation levels and validation action. So you can say, okay, well, I want this amount of stuff to be different to be okay, or in certain situations I want the whole document to be rejected because it fails that validation. At other times you just want to warn, hey, are you aware this document doesn't quite fit the schema? And so the schema, you can do things with the validator, like specify that the title and plot are required. For every movie, we want to make sure it's got a name, because every movie has a name, so we want to make sure we store it. But we also want the plot, so that if we get nothing else about the film, we at least know what it's called and what it's about. Or we can say things like, the name field has to be a string, and then we can give a description so that when it's rejected for that reason, we come back and say it must be a string and it's a required field. So, if you want to put that validation in, you really can. you can use the JSON schema rules or expression validation just to make sure that it's in the shape that you want. So you can be flexible if you want. If not, don't panic. Okay, we've mentioned it a few times now, but it's time to actually dig deeper into it. So let's talk about common design patterns. So MongoDB has many design patterns, and in fact, there's a variety of blog posts that we can get shared, but we've got loads of blog posts that we can come on to later. Don't worry, you will get the link to it. But design patterns are essentially common practices been battle tested for specific use cases. They've been created and come up with by, really super clever engineers who've worked at MongoDB for a very long time, who've come up with these design patterns because they are, they're often the perfect solution for many different use cases, which might include yours. Then we've got the polymorphic pattern, which is a variety of document types in a single collection. We've already seen that, right? As we said, flexible schema is basically polymorphic pattern in action. You've got pre-allocation. So if you know what your document structure is going to look like, but you just haven't got data yet, that's okay. Just use pre-allocation. You know what it's going to look like, and then as you fill it out with data, it's going to meet that structure. Then we've got a subset. So that solves the problems of having too much data per document in a collection. So 3 different types of design patterns. And actually, there's this really cool table here. And as I mentioned, don't worry, this webinar is being recorded, so if you want to come back and look at this table later on in your own time, you can. But it just goes through some different use case types here, like the, outlier pattern, and then it, gives you examples of maybe some use case categories where you might want to use that design pattern. So really, really helpful. Lots of different design patterns. And in fact, one of the ones I want to talk about now is the outlier pattern. And there's a link at the bottom here. This is one example. So if you go to this link, it's one in a series, and that series is what you find on this page here. But it's lots of great blog posts that talk you through some of the different patterns that we're not going to cover all the patterns today because there's too many. So these blog posts are great. But let's just talk about the outlier pattern. So imagine that you have a book. So this book is actually written by my colleague's brother, which is wonderful. Actually, Mike does the podcast. So it's his brother that's written this book. And imagine that you've got this field that logs all the customers who bought your book. But can you see a problem here? What might be an issue with this? Yeah, that if it's a book like this, like Harry Potter, for example, we might hit problems where there's so many users that we're actually hitting the limits of a document, because the maximum size of the document can be 16 megabytes, which might not sound like much, but data like BSIM documents take up no space at all. So 16 megabytes is very generous, but you might hit issues where this is a problem. So this is where we can have a new field. Now you can call it whatever you want, but in this case, we've called it has extras. And this is set to true. And this is basically saying, okay, well, we still, we've set a limit that we've decided that maybe we only want to keep 10, 100, 1,000 customers listed in this array. Once we hit that point, we want to flick this has extras as true. This will then go ahead and store the additional customers purchased from this in a separate collection. And that's okay. We still have all the data and we can still easily access it, but we're just not storing it all in one place, because as you start to have too many users or, whatever it is stored, this is the idea of arrays and unbounded arrays. We don't want to have an array that has an unlimited, unbounded size, because you can hit document size limits, or it's just not efficient. So it's better to just use something like this, the outlier pattern, where once you hit a certain array size, for example, you then just say, go and find it somewhere else. It allows you to store it all in a single document, but offload less commonly accessed data to a separate collection. This is just giving you some choice. Just gives you a way to handle lots and lots of information. As I say, if you want to read further, there's this blog post from Daniel Kupal and Ken Alger. They've got a whole series on not just the outlier pattern, but loads of other great patterns. So I very much encourage you to go and read them. Okay, then we've got quickly cover some common design patterns, because it's all well and good having the positive, but it's good to be aware of anti-design patterns as well, because they do exist. We want to avoid them. One of those is massive arrays. So as we said, unbounded arrays are a bad idea. You want to try and avoid them. Take advantage of things like the outlier pattern to handle massive arrays. Also, massive numbers of collections. One of the things we see a lot is that people from a relational background will come in to start using MongoDB and start trying to map their collections, tables to collections, and start ending up with a massive node of collections. But actually, if they're not being used very often, or the data is being accessed together a lot, it shouldn't be in a massive number of collections. That's where embedding comes in. Unnecessary indexes. So if you don't know, an index is basically a great way of identifying fields of data that you access regularly, and it will then store it in basically what we call a working set, which is basically the RAM of the server that you can then get to quickly. But of course, this comes at a cost. If you then write documents to your collection, you have to update the index. And so you want to avoid unnecessary indexes. You know, it helps. It's great for reading, but it's not great on writes. You want to avoid it. And then bloated documents. Storing way too much data together in a document when it's not frequently accessed together is also its own anti-pattern. You know, we might talk about data that's accessed together should be stored together, but not always. And then separating data that's accessed together. If it's stored, if it's accessed together, don't separate it, you know, out. That's just an anti-pattern. Run away. Have a look at the way you can store it together, you know, using things like embedding. So, you know, we'll talk about bloated documents. So, you know, bloated documents is an anti-pattern. So we've got all this information here, like title and plot and reviews. But when you think about something like reviews or facts, do you really need to access it every time that you get this document out? You know, when you're accessing this movie document, do you really need, you know, the 1500th review or, you know, all the facts? You might not. So you want to avoid things like this. Remember, it's all the opposite of our mantra is also true. Data that will not be accessed together should not be stored together. And just quickly talk about the schema advisor, because the Atlas has a schema advisor in it to help you improve. What it does is it automatically recommends improvements. So as your data is accessed over time and more people use it, Atlas is looking for patterns for the data and the way it's accessed to help make suggestions, such as, you know, maybe create some indexes. Are these fields being accessed very frequently? Maybe you should index them to improve read performance. Avoid those unbounded arrays. You know, you'll look out for them and say, hey, you know, maybe you don't want to do these. And now you know if that happens, maybe you want to start doing something like outlier pattern. Reduce the size of large documents. Maybe you don't need those documents to be as bloated as they are, so it can make recommendations. Reduce dollar lookup. So yes, we can do referencing. The way that we do referencing is with an aggregation stage. I think it's an aggregation stage, but it's using an operator called the dollar lookup operator. And actually, sometimes if you're using the dollar lookup operator too much, it's possibly a sign that you're using referencing too much, and maybe actually there's better ways to model your data. And this is just here in Atlas. When you have a look at your cluster and you're inside of it, you can just go to Performance Advisor, and it will start to, you know, actually give you some recommendations. Obviously, it's not necessarily going to be there straight away with the recommendations because you need to use it a little bit, but over time it will start to work. Okay, we're gonna end with a little bit of a quiz for a bit of fun. So, first question is going to be, let me just get the shut up so I can see your answers. Yeah, so data is accessed together. Absolutely, everyone's getting it right. Should be stored together. Smart people, well done. Okay, next question. What is the name of the MongoDB podcast? I did mention there's two, but what's the name of the English-speaking MongoDB podcast? Yep, cool, you're all right, excellent. See, super smart people. So as I say, it's hosted by Mike Lynn and Shane McAllister. They have great interviews with different customers, engineers, people on the team. Even interviewed me once, which was a lot of fun. Okay, what happens to all the previous documents when you modify the data model? Nothing, because polymorphism rocks. There's documents that's deleted. They're migrated to SQL. Ugh. We have a podcast, you know. Yeah, everyone's smashing it. Great. Exactly. Okay, and quickly at the end, what is the default preference for data modeling in MongoDB? Yep, absolutely. You're all doing a great job. Just remember, data that's accessed together should be stored together. And I'm going to keep saying that over and over and over again so that you remember. And so, there we go. We've got through our whistle-stop tour. So we covered a lot today, but just there's lots of additional resources if you need them. So there's the blog post about design patterns. There's a summary of how to spot anti-patterns and, maybe types of anti-patterns as well. And also best practices. And more importantly, there's also a survey. So, please share your feedback. It's really important. It's a great way for you all to have some input on what you want the next sessions to look like, or we have webinars on a regular basis on different topics, whether it's webinar data modeling or something else. And so that's super, super important. And so with that, we will try and finish with some Q&A. It's always fun doing Q&A, but these sessions, there's always so much great stuff to tell you. So let's see. So we've got the poll. So please take a minute to fill out the survey. And then we'll try and do some Q&A if we've got time. Let's have a look. Okay, what have we got? So we've got some questions. I don't know if either Dominic or Diego want to come on and ask the questions on camera. No pressure if you don't. I'll answer them without you.
I mean, we've left a couple for you open. I'm happy to do the moderation, but if you want to answer them.
So we'll quickly just try and answer a couple of questions.
Yeah, so the first one is about the referencing part. While doing relationship to MongoDB, how can I achieve constraint checks before any kind of CRUD? So the example that is being given here is we can configure an RDBMS to disallow deletion of parents if the child exists, so one cannot insert a child without a parent. But I guess it's just about constraints in general.
Good question. So I think a lot of it again comes down to how, I guess validation is important. Like on reads, I mean, certainly like if you're doing things like CRUD, like you mentioned, then certainly with with things like rights, you can even our drivers support setting up validation. So, if you try to use CRUD in your application and it fails validation, then it will come back to you and say, hey, no, bad idea, don't do this. In terms of parent and child, I'd have to try it and see, because I've never really thought about parent and child, because often we embed so often. Yeah. I'm not sure. That might be a good one for the forums.
Yeah, I guess it also comes down to the specific example. So if Sujan, if you want to just post it into the forum and feel free to tag us, that's certainly one option. So there's another good one here that was about the indexes. Is there a recommended maximum of indexes that you should create per collection?
I don't think there's a set number, because it's very much, I know it's a typical developer answer of it depends, but I don't think there's a set number of indexes, because it will all depend on things like the size and shape of your data. But that's where things like Schema Advisor are so useful, because if you start having too many indexes, it will make recommendations either, maybe don't use this index, or try using different indexes or anything like that. Another good one with indexes is we have something called explain. So when, say, for example, you're in the MongoDB shell and you're, carrying out a query, maybe it's a find, rather than doing, collection.find, you can actually do collection.explain.find. And what that will do is actually come back and let you know how your indexes are performing in that query. So you can actually see either with or without the Schema Advisor, maybe where your indexes are performing well or not.
Great. Do you want to go to another question?
We'll do one more. I don't want to keep people too long.
All right, let's go. The last one here is also probably interesting for others. For schema versioning, could you also use semantic versioning, like major, minor, patch, or does it have to be an integer?
I'm guessing you could do major, minor versioning, because I think we're using integers in that example, but because we support multiple data types, that version isn't a set in stone, like, hey, MongoDB, this is a version. It's just a field that you might want to specify in your document to make it clearer to you that you've got different schema versions. So if you want it to be an major, minor, you could always make it a string with major, minor in it if you want to.
Cool, thank you.
No worries. We've got lots of different, bits of resources here, especially the forums. The forums are a really great source of information, whether it's, learning or you got questions and you want them answered. We've also got our new Learn platforms. We've had University for a while now, but we've just launched the Learn platform. It's sort of, University, but redone and improved massively in the past few weeks. And so that's a great place to start, because there's actually courses on Intro to Data Modeling. I think it's called M320 or something. But yeah, there's loads of resources to learn more about this stuff. So it's well worth, not just watching the recording of this webinar again if you need to, but going on the forums, asking questions, reading those blog posts, or going on Learn. There's a breadth of resources out there to learn more about this stuff. Cool. Well, I guess with that, we can end the webinar, but thank you everyone so much for joining. I hope you found it valuable. As I said, there's lots of resources out there. So if you have more questions, the forums are a great place to go, or our docs, or our Learn platform.